we're going to now do a little bit more with solving linear equations, extending on a couple of concepts learned earlier. Starting here with something a little bit bigger. So as we go through this, working through our order of operations, first thing I need to do is I need to distributive property. So 2x minus 6 minus 17 equals 13. This is, again, the tricky part. Always remember when there's a negative in front of a distributive and property, that negative will distribute to both items, negative 3x minus 6. As always is the case, if there's ever a time when you're looking through a video and something isn't making sense, that's when you need to ask a peer, study group, instructor, myself, you name it, get clarification. Going to now simplify each side. All right, again, hitting pause and making sure you're understanding where all the parts and pieces are going and coming from. Going to add 3x to both sides. I'm going to combine a step here. I'm going to add 23 to both sides as well. Making note that this and this are identical. Whatever I am doing on one side, I'm doing the exact same thing on the other side of the equation. Divide both sides by 5. X equals 6. A good check is to take this number back in for each of the x values and see that it actually works out. When dealing with fractions, many people do not like fractions. So what I've talked about and will continue to say is look for the lowest common denominator amongst all three of them. And in this case, I have my denominators are 2, 5, and 10. The number that all of them can go into is 10. 10 goes into 10, 5 goes into 10, 2 goes into 10. So I'm going to take and multiply everything by 10. As a fraction, it's 10 over 1, so that would be 30x over 2 equals 10x over 5. Again, because there's a 1 right there, 1 times 10, minus 780 over 10. All right, so what do we end up with? We end up with 15x, because 30 divided by 2 is 15, equals 2x minus 78. Subtract 2x from both sides, so I have 13x equals negative 78. Then divide both sides by 13. I'll leave that to you. When I have decimals, remember decimals in terms of places. First place of the decimal is the tenths. This is tenths, hundredths, tenths. So I have tenths, or think 10. I have hundredths, or think 100. Both numbers go into 100. 100 goes into 100, 10 goes into 10. I'm going to multiply everything by 100. I will have 70x, because I moved the decimal place twice. 1, 2. Okay, the x moves over, but I have 70x equals, this moves over, 21. Oh, sorry, that is not an equals here. That's a minus. Now I have equals, and the decimal moves over twice. 1, 2, 3, 50. Now it looks like equations we've done a bunch of. Adding 21 to both sides. 70x equals 371. Divide both sides by 70 to get a final answer of x equals some value. Leave that one up to you as well. Let's work on this next one. So we have 2x plus 6. Habit, I see these, I'm thinking distributive property. 2x plus 8. I'm going to subtract 6 from both sides. I have 2x equals 2x plus 2. I'm going to subtract 2x from both sides. I am left with 0 equals 2. And then you wonder, did I do something wrong? In this case, I know we did not. In a case like this, we say 0 equals 2. When does 0 equal 2? It never happens. Therefore, no solution. In other words, when looking at this original equation, when will 2x plus 6 equal this? And the answer is never. There is no answer to this. There is no solution. This one I'm going to start a little bit simpler. X plus 5. When does x plus 5 equal x plus 5? It always equals x plus 5. So if I were to start working on this and start saying, out of habit, I subtract x from here, I subtract x from that side, I'm left with 5 equals 5. How often does 5 equal 5? 5 always equals 5. Therefore, every x is a solution. That is, there are an infinite solutions. There are infinite solutions. Any number you put in for x, doesn't matter. Add 5 to it, still the same number, always the same. So you're either going to, when you're solving one variable equations, either x will be a single number, x could be no solution, or x could be an infinite number of solutions. That's it on single variable equations.